Alright, good afternoon everyone. Welcome to our Sec 4 E-Math lesson. I almost said A-Math. Every Saturday at 2 p.m. with me, teacher Humphrey. Not always with me. I'm taking over teacher Jason's lesson today because he is away. And yeah, so hope you guys have fun. My name is teacher Humphrey. Okay, so let's just begin. Okay, so before we begin, please make sure that you have your pen, paper, and calculator ready so that you can participate in today's bubble questions. And yeah, general rules as always, please be patient and understanding, observe gracious and respectful behavior, and last but not least, ask good and relevant questions. Okay, so today we are going to do our revision. Okay, we're going to start our revision already. So Sec 4 E-Maths finishes the topics really fast, right? You finish learning everything you need to know for Sec 4 E-Math. The new topics will mostly be in A-Maths. So for those of you who are only taking E-Math, then good for you. More time to study. Okay, so we are going to start with all the Sec 1 to Sec 4 topics. Everything can be tested. Every single thing that you learn throughout the whole Sec 1 to Sec 4 can be tested. Okay, so buckle up. This lesson should be quite easy. If you take a look, most of the questions you should be able to do. So hopefully free bubbles. Okay, so take this as a revision lesson and let us start with the first topic recap of the day. Will be prime factorization, HCF, and LCM. Alright, so this is the very first thing that you learned in secondary 1. So hopefully you guys still remember. So prime numbers. What is a prime number? Anyone tell me, how many factors does a prime number have? Anyone? How many factors does a prime number have? Actually, it's right here, right? There's 2 blank spots. So that means there are 2. Okay? So, what are the 2 factors? Okay, good. Thank you, Chen Zheng. Chen Zheng, is it? 1 and itself. Okay? You can only divide by 1 and itself. Alright? So, next. Highest common factor. What is the highest common factor? So, if you have 2 or more numbers and you want to find the highest common factor, that means we want to find what is the number that divides both of the numbers and is the highest number that it can do so, right? So how do you find it? How to find HCF? We will multiply the what's the thing? Okay. Okay, so this should be factors. Whoops. Okay. We need to multiply the common prime factors with the lowest powers. Okay. So it's a bit counterintuitive, right? You want the highest common factor, but you take the lowest powers, right? Because you are taking the how do you say, the smallest power so that both numbers have that power, right? If you take the highest power, then the one with the lower power will not have that factor. So you take the lowest powers. Okay? So to find lowest common multiple means you want to have a multiple of both numbers, right? So same thing, this is factors. So to find LCM, we multiply the common prime factors with the highest. Okay, it's the opposite. Okay, if you want to find HCF, you'll take the lowest powers. If you want to find the LCM, you'll take the highest powers. Okay, can? Alright. So, next, what is a perfect square? Perfect square is something that you can represent as something squared, right? Like let's say 4 squared is 16. So 16 is what you consider a perfect square. Okay, so how do we define it? When written as a product of its prime factors, the indices of each prime number is a multiple of what? What should the indices of each prime number be a multiple of? Anyone tell me? What should the power of each thing? Okay, correct, Isabel. You need it to be even. That means that it has to be a multiple of 2, right? Multiples of 2 are even numbers. Alright? How about for perfect cubes? So perfect cubes means that you can represent it as something cube, right? So your indices must be a multiple of what? So it's cube, that means you have power 3, right? So it will be 3. Okay, so if you have power 6, that will also be considered a cube, because using your laws of indices, let's say 2 power 6, you can represent it as 2 squared whole thing cube. So it's actually 4 cube. Alright, now let's go through the first work example of the day. Given that x equals to 2 cubed times 3 squared times 5, find the value of k, where k is a positive integer such that x over k is a perfect square. Alright, so we want x over k to be a perfect square. Let's write out our x first. Okay, copy the question as always. And we want to find x over k. Okay, x over k is 2 cubed times 3 squared times 5 over k, right? We want it to be over k. So what should this k be such that it becomes a perfect square? So you have to look at each of the factors and then divide such that you will remove the factors, right? So if you look at 2 cubed, if I want to make it a perfect square, I have to divide by 2, right? I divide by 2, I'll get 2 squared, which will be a square. How about 3 squared? What do I divide by? I don't need to divide by anything, right? Because it's already a square. And last but not least, if you times 5, this 5 is power 1. So power 1, how do I make it even? I have to divide by 5, which makes it power 0. Okay, so divide by 5, which is the same as multiply 5 in the denominator. Alright, so I'm basically removing one factor of 2 and one factor of 5 such that I get 2 squared times 3 squared times 5. Oh, not 5 anymore. The 5 and the 5 cancel out. Alright, so this will be your perfect square. So what does that mean? It means that this k is the same as the denominator here, which we just wrote out. Therefore, k equals to 2 times 5 equals to 10. Okay? Simple question. Let's not waste too much time and try out the Bible question. Alright, so first Bible question of the day, really quick, 1.5 minutes. So we want to find out what is the value of m and n such that x times m over n is a perfect cube. Alright, so your time of 1.5 minutes starts now. I see we have a student who just joined. Hi, haven't seen you before. My name is Teacher Humphrey. We are currently in Bible question 1. Alright. 15 seconds left. And 3, 2, 1, time's up. Okay, so we want to have x equals to 2 power 4 times 3 cubed times 5 squared. So we want x times m over n to be a perfect cube. Okay, so x times m over n to be a perfect cube. So let's just assume that m is not 0, okay? Because if m is 0, then 0 is technically a perfect cube because it's 0 power cube, right? So, okay, so we're going to copy out x and then times this fraction over here, which we want to find out, okay? So what do we do? How do we make it a cube? So if we look at 2 power 4, to make it a cube, we have to divide by 2, right? Divide by 2. And if we want to make 3 cube a cube, it's already a cube. So don't need to touch. Alright. Now 5 squared, if we want to make it a cube, we have to multiply by 5. So, aha, now we have m equals to 5, n equals to 2. Alright, so I would think there should be this smallest in this question. So, yeah. Okay. Now, let's move on. Nobody has any questions, right? Everybody got it right. Wow, that's literally everybody got it right. Okay, great. All of you should be very confident in your Sec 1 knowledge. Okay, next question. Find two numbers, both smaller than 101, that have a highest common factor of 10 and lowest common multiple of 900. Okay, so we know that HCF is equal to 10. Okay, HCF is equal to 10, which we have to convert into your prime factorized form. So 2 times 5. LCM is 900. Okay, so how to convert into a, what's that called? Prime factorized form will be 2 squared times 3 squared times 5 squared. Okay, quick note, you can straight away see the 100, right? 100 is 2 squared times 5 squared. So you can do it a bit faster. Alright, now we want to make it such that you have two numbers that have the HCF of 10 and LCM of 900, right? So how do we do that? We're going to, okay, first of all, we want to rewrite this so that everything is lined up. Okay, your powers of 2 should be together and your powers of 5 should be in the same column. Okay, so now we want to find out what combinations of factors will give you two numbers that are smaller than 101. Okay, what combination will give you smaller than 101? So you just need to take what's that called? So if you see two things here, right, that means that one of the numbers must contain a 2, so that when you find the HCF, you'll choose this 2. And the other number will have 2 squared, so that when you choose LCM, you'll choose this 2 squared. Okay, so you just need to find, split up this 2 and 2 squared, and this is times 3 power 0, or this is power 1, right? You will split up these factors into the two numbers such that you get less than 101. Okay, so in this case, I would take the first number to be 2 squared times 5 squared, because just now I said 2 squared times 5 squared is 100, right? And that is the closest I can get to 101. Alright, so that means that I chose this number, and this number to go into the first number. Okay, that means that the remaining part should be this thing here. Okay, so I will get 2 times 3 squared times 5 gives me 90. Alright, so that's how you get two numbers such that they are both less than 101. And if you do the HCF and LCM thing, right, you should get the 10 and 900. Alright, any questions with this question? Anyone has problems seeing this, how to do this kind of question? Okay, so Sec 1 level, right? It's just that it's slightly harder for Sec 1s, but now that you guys in Sec 4 should be used to this kind of questions already. Okay, so let us try in bubble question 2. Bubble question 2, we have 1.5 minutes, okay? It's 1.5 minutes and your time starts now. Maybe quick show of hands, how many of you have already watched Miss Teacher Kim's lesson? Actually, yeah, right? So you guys should know the answers already. Okay, so I'll spend less time on going through the answers. Maybe more time on explaining in the work examples. Okay, so maybe there's a few tips that may differ between the lessons, so you can pick up on that. Alright? And 3, 2, 1, time's up. Okay, so they give you HCF and LCM. We are going to factorize them. Okay, so HCF is 24, which is equal to 2 cubed times 3. LCM is 5040. You can slowly factorize it. You get 2 power 4 times 3 squared times 5 times 7. Okay, so how do you split up these factors such that you can form two numbers that are greater than 300 but less than 400? Alright, so we're going to choose which ones? 2 cubed and then 3 squared, and if I multiply by 5, this one should give me 2 cubed plus 3 squared, that is 8 times 9, 72 times 5, 360. Okay, so 2 cubed times 3 squared times 5 is equal to 360. Okay, so as long as you hit this range, right, you should be pretty safe. Okay, you just need to double check with the other number, make sure that it's between 300 and 400. Okay, so the other number will be this, this, and this. So 2 power 4 is 16 times 3, 48 times 7 is 350 minus 14, 336, right? 2 power 4 times 3 times 7 is 336. Okay, so that is your two numbers, 360 and 336. Answer option 1. Okay, of course this is a bubble question, MCQ, so if you really wanted to, you can go and try all the options and get the HCF and LCM, but in the exam you have to know how to split up the factors into the two numbers. Okay, can? Next, simultaneous linear inequalities. So this one is what we learned in Sec 3, right? Sec 3 we started learning Sec 2 we started learning inequalities, then Sec 3 we combined to do simultaneous inequalities. Okay, so first part is find the range of values for x such that x more than 1 and x more than or equal to 3. Okay, so how do you draw x more than 1 on the number line? It is going to be, since it's a strict inequality, you have a white circle and then all the way, draw your arrow all the way. Okay, then what? X more than or equal to 3 means you'll draw a black circle and then all the way. Okay, so how? What do you do? Simultaneous linear inequalities, right? That means you have to find the shared region. Shared region will be this part here. Okay, so what's the answer? It should be x more than or equal to 3. Okay, because you take note that you are including this 3. Okay, so make sure that you include the 3. Now, what happens if you want to find the range of values for which x more than 1 and x more than 3? So x more than 1 is white circle more than. Draw your arrow all the way. Okay, and for x less than 3, strict inequality, so white circle and all the way. Okay, so now shade the region, the shared region, and you can see that the two ends of the region are white circles, right? So you have strict inequalities. X is between 1 and 3. Okay? Alright. Let's try a few more. What happens if x less than 1 and x more than or equal to 3? So x is less than 1 and x is more than or equal to 3. Okay, so what will you say? What is the shared region? How would you phrase this? There's no answer, right? There is no shared reason, so therefore you say no solution. Okay, or you can just say NA, not applicable. Okay, now if x less than 1 and x less than 3, we have white circle to the left, white circle to the left. So the shared region will be this part here, right? So answer will be x less than 1. Okay, now let's go on to the harder kinds of questions. So this is also considered under your simultaneous inequalities, where you have the inequality and then another inequality, right? And there's algebra inside. So when you see this kind of inequality, right, what do you need to do? First things first, okay, copy down the question. 2x minus 1 over 3 more than or less than x plus 1 less than or equal to 1/4 minus x. So what's the first thing we need to do? We need to split, right? We need to split into two different inequalities. First one is 2x minus 1 over 3 less than x plus 1. And, okay, take note, use the word and. Alright, because it must happen at the same time. It's a simultaneous inequality, right? So they are happening at the same time. Okay, so and x plus 1 less than or equal to 1/4 minus x. Alright, so take note, the inequality you use is important. Okay, whether or not you have less than or including or strictly less than. Okay. So, first inequality, let's solve it. Okay, 2x minus 1 less than 3x plus 3, right? I multiply both sides by 3. Since I multiply by a positive number, nothing happens. I just multiply. Okay, then what? I can bring the 2x over. So, okay, I'll get x on the right hand side, and then I minus 3 on both sides. I have minus 4. Okay, so take note when you write this, right? Make sure that you change it back such that the x is on the left hand side. Okay, always make sure that the x is on the left hand side. So take note that the inequality will flip as well. Okay, we are just reversing the whole inequality. Alright, now write the next inequality, x plus 1 less than or equal to 1/4 minus x. We can multiply by 4 on both sides first. 4x plus 4 less than or equal to 1 minus 4x. And then plus 8x on both sides. Minus 4 on both sides. So minus 3. Yep. Okay, so therefore x less than or equal to negative 3 over 8. Okay, so when you reach this step, right, make sure to show that you combine the two inequalities together. Okay, so because you are using the word and, right, this and, it means that you have to combine these two inequalities together. What is x more than 4, more than negative 4, and at the same time it is less than negative 3 over 8. So that would become negative 4 less than x, okay? And then, which is also less than or equal to negative 3 over 8. Okay? So all you need to check is my negative 3 over 8 more than negative 4? If yes, then yeah, that's your answer. Okay? If it's not, then you have a problem. No solution. Alright? So that is the answer. Part B asks you to illustrate your solution on a number line. Okay, so I'm going to draw the number line. Okay, and we have since everything is negative, let's just put as 0, 1, 2, 3, 4. Oops, it's all negative. And negative 5. Okay, just one more number for extra measure. Now, we want what? X is more than negative 4. X is more than negative 4, strictly more than. And x is less than or equal to negative 3 over 8. Okay, so take note, when you draw your 3 over 8, negative 3 over 8 on your number line, right? Take note that negative 3 over 8 is slightly less than half, right? It's less than 4 over 8. So you will draw your negative 3 over 8 to the slightly closer to the 0, okay? Near half but slightly closer to 0, so that you keep the scale there. Okay, so this is negative 3 over 8. I will draw a black circle and it's less than, okay? So that means the shaded region, which is the shared region, is your answer. Okay? Now, part C. This was part B. Part C. Write down the integers of x that satisfy this inequality here. Okay, so can you tell me right now, what are the integer values of x that satisfy this inequality? What are the integer values of x that satisfy this inequality? What is an integer value? Okay, if you say -4, then I'm sorry, you don't get any marks. Okay, so take note that you do not include -4 in your answer, right? This is a strict inequality. So you want it to be strictly more than -4. Okay, so you should start counting. It's only the numbers here. Okay, you can see from your number line, these are the integer values of x that are within the region. Okay, so therefore, x equals to -3 or -2 or -1. Okay, these are the three integer values of x that satisfy your inequality because they lie within your solution region. Okay. Okay, let's go on to Bible question 3. Okay, so this is slightly different from, okay, not slightly, very different, right? But this is what we call the real world context question. Okay, so real world context question is very, very, very common in your exam. So you have to be able to translate the information into your math problem. Okay, so gonna give you 1.5 minutes. Okay, 1.5 minutes, and your time starts now. Ten seconds left. And 3, 2, 1, time's up. Okay, so we have this problem where you have an IQ test with 40 multiple choice questions. Each correct answer is 5 marks and wrong answer -2 marks. Okay, so let's just say we introduce the variable x. Let x be the number of correct answers. Okay, let x be the number of correct answers so that we can use algebra, because they did not introduce any x inside the question, so we have to write this. Okay, so therefore number of wrong answers is just 40 minus x, right? The remaining answers. Okay, so what is the formula for the number of marks? Number of marks will be every correct value will be 5 marks. So 5x. Okay, 5x. Then what? I will minus away 2 marks for every wrong answer. So minus 2 times 40 minus x. Okay, so let's simplify that. 5x minus 80 plus 2x. We have a formula 7x minus 80. Okay, so we want to find out what is the he answered all questions and his score was more than 140 marks. Okay, so he said that the score is more than 140 marks. Therefore, this 7x minus 80, this 7x minus 80 must be more than 140. Okay, so let's solve for x. 7x is more than 220 and x is more than 220 over 7 is 31 and 3 over 7. Okay, so they want you to find the minimum number of correct answers he got. Okay, so this cannot be option 4, right? Because number of marks is an integer. Okay, you have to have a whole number of correct number of questions. Sorry, number of questions that he got right. So you can't have half a question correct, right? So it has to be a whole number. So in order for you to round off, okay, take note that even though 31 and 3 over 7 looks like you have to round down, right? But when it comes to inequalities, you have to make sure when you round off, the inequality still holds. Okay, so if you round down, it's 31, right? But x has to be more than 31 and 3/7. So x cannot be 31. Okay, so you have to round up instead. Okay, so you round up. Okay, so x is more than or equal to 32. This is the minimum number of correct answers, where the number of correct answers is an integer. Okay, 32. So this is your answer, option 3. Okay, can? Alright, let's move on. Laws of indices. I believe this is one of the harder topics, right? Where you have to remember so many different rules, right? But no choice, have to remember. Okay, so can you tell me what is a power m times a power n? Am times an. Okay, very good. A power m plus n. Alright. Now, what is a power m divided by a power n? So if you have multiplication, you add the powers. If you have division, okay, thank you, Nicole, that is, you minus the powers, right? So whenever you see divide, right, this division basically means negative power, okay? So just remember division as negative power, all right? And multiplication means positive power, all right? So am power n. Now, if you have am and then you power n, so you can apply the power in succession, right? So that is a power m times n. Okay, you multiply the powers together. All right. So next, am times bm. This is what? What happens when you have the same power but different base? Same power, different base. Means that you can kind of factorize the power, right? You can put the power outside, okay? AB whole thing power m. Okay, because the bracket tells you that, oh, I'm going to do whatever I'm doing outside the bracket to everything that's inside the bracket. Okay, so I'll take a power m and then I have b power m. Okay, so same thing backwards. If I see ab power m, I'll have to apply the m to both a and b. Okay, take note, this is a very common problem that you'll miss. Okay, so make sure that when you see brackets, or you will apply the power to both things. Okay, now am divide by bm, same thing, you have the same power, so I can just take it out and I'll be left with a over b power m. Okay, so I'm applying the m to both the a and the b, so I'll have am, okay, I don't need this bracket anymore, am and divide by bm. Okay, I apply the m, the power m to both a and b. Alright, now next, zero indices. What is zero indices? Means that you have power 0. Can you tell me what happens when you put something to the power of 0? Okay, very good. You get 1. Okay, so anything power 0 is 1. Next, negative indices. Just now what did I say? Negative indices means division, right? So, or rather I said division means negative indices. So if you see negative indices, it means that you are dividing by a over n. Okay, so that means it will be 1 over a power n. Alright, so if you have a over b power negative n, what does that mean? What do you think that means? What happens when you divide by a fraction? What happens when you divide by a fraction? Anyone? No? If you divide by a fraction, that means you are multiplying by the flipped fraction, right? So if I say, oh, I have 2 over 3 times, or rather, okay, if I have 2, divide by the fraction 4 over 5, okay, this will be 2 times 5 over 4. Okay, so I have to flip the fraction. Okay, so that's what it means to put the negative power, you apply it to a fraction, it means you flip the fraction. Okay, then take note that there is still a power n, right? So you have to multiply the n into both things, both the numerator and the, not multiply, you apply the power n to both numerator and denominator, so you end up with bn over an. Okay, great. Now fractional indices. So just now is negative indices. Now what happens when you have fractional indices? Okay, so fractional indices, I want you to always remember what is a half. A power half is basically your square root of a. Okay, so it's because you need to multiply square root a with, square root of a times square root of a equals to a, which is power 1. Okay, so if you use your first law of indices, which is you add the powers together, right? This square root a must have a power half. Okay, so now if you see a power 1 over n, that would be your nth root. Okay, nth root of a. So that you have to multiply the nth root of a n times in order to get back your a. Alright, last but not least, if you have a power m over n, what do you get? It's very similar to the previous one, right? Just that you can think of it as this is a1 over n times power m, right? Because the powers multiply together. So therefore, you get n nth root of a and then power m. Okay, so the denominator will always become the number over here. Okay, this is the denominator of the power, and the numerator is just the power on its own. Okay, you just multiply that power. Okay, now let's try. Given that you have this whole equation, woof. Okay, so let's copy it out first. Copy it out. And then we will simplify. Okay, so a cubed squared. What's that? You have to multiply the powers together, right? a6 times a1 over 5. Okay. Now, if you see divide, a power m, yeah? Did I copy wrongly? Correct, right? The right hand side is here, a power m, right? Okay, I'm just copying out the whole equation first. Okay, so when you see divide by negative, oh, you are referring to the previous one. This one, right? It's because of the way you split. Okay, so it means the same thing. Okay, let's erase this. Okay, I'll just go through this quickly, okay? So if you write it as a power 1 over n times m, that means your m will be on the right side, right? So this part is nth root of a. Then you put the bracket, power m. But you can also write it as am times 1 over n, which is the same as am, and then you power 1 over n. Okay, so you can write it as the nth root of am. So that means to say that this thing is exactly the same as this thing. Okay, so it doesn't matter which one you write it as, but when it comes to calculations, one of them will be easier to calculate, of course. Okay, Nicole? Okay, let's go back. So let's continue to simplify. If you see division, division means you will take the negative power. Okay, so we can write it as times, times, wrong color, times a, you take the negative of whatever power is there, you'll end up with 8 over 10. Okay, and this is am here. Now, we want to combine everything. So if you see multiply, right? If you are multiplying, that means you will add the powers. So everything will add up. 6 plus 1 over 5 plus 8 over 10 in the power equals to m. Oh, sorry, not m. A power m. So that means that if we calculate what this thing is, you'll have a power 7 and equals to a power m. So once you reach this step, if you have the same base, that means, and same base and is equal to each other, right? That means that the power is the same. Okay, the power is the same. So that means you have m equals to 7. Final answer. Alright. Now, let's try. Bubble question 4. Make sure you can do this. You have 1.5 minutes and your time starts now. 30 seconds left. Five seconds. And time's up. Okay, so b squared times b0 power 3 divided by 1 over b power negative 5 equals to b power n. Okay, so if we simplify the first part, b squared times b0 power 3 means that we will multiply the powers into the two things inside the brackets, right? So this is b power 6. Then you see, oh, b power 0 is 1. So I don't need to, I can just multiply by 1, right? Now, divide by 1 over b power negative 5. If you are dividing by a fraction, it means you are multiplying by the flipped fraction. Okay, multiply by the flipped fraction b power negative 5. Okay, over 1, but you don't need to write the over 1. Alright, so equals to b power n. Then just multiply everything together. Means add up the powers. 6 minus 5 is 1. Equals to b power n. Oh, just nice. N equals to 1. Done. Okay, option 2. Alright. Now, next question. About question 5, 1.5 minutes. Let's do this. And your time starts now. Thirty seconds. In 5, 4, 3, 2, 1. Time's up. Okay, so we have half power x times 8 power x plus 1 equals to 64 2x minus 1. Okay, so this question is a bit trickier because you have to convert into the same base. Okay, remember that to solve an exponential equation, you have to change to same base. Okay, so half, we can convert it into 2 power negative 1. Let's multiply that with the power of x. Okay, and then times, now 8 is 2 cubed. Okay, it's very useful to memorize your powers of 2. Okay, 2 cubed, which is, and then you multiply with the power that you have. Okay, so your power becomes 2 power 3x plus 3. Now, 64. 64 is 2 power 6. Okay, if you can't remember up to 64, you just do 2, you count. Number 1, 2, right? 2 power 1. Then 4, 8, 16, 32, 32, and then 6 will be 64. Okay, so this is 2 power 6. So I multiply the 6, I get 12x minus 6. Okay, now we will combine everything. This is add the powers, right? So I have 2x plus 3, and then this remains here. So now that I have the same base equals to each other, my powers will be the same. Okay? So now we will solve for x. Okay? So solve for x, you have 10x equals to 9, x equals to 0.9. Okay? Option 4. Any questions? I think this one had a few people with careless mistakes. Okay, but should be doable, right? Okay, last question. Now, this is your standard form question. Okay, what is standard form? Standard form just means that it has to be, you have to make it a decimal with only one digit at the start. Okay, and then you have the times 10 to the power of something at the end. Alright, so you have 1 minute, okay? 1 minute to answer this. Okay, so a bit short on time, but 1 minute and your time starts now. Okay, time's up. Power 10. Yep. Actually, if you key this into your calculator, right, you will immediately get your answer. Okay, so would be good if you show a bit of working. So let's do it manually. Okay. You have this thing here. Okay, so first we deal with the numerator. Okay, if you multiply 2 into the brackets, right, inside your brackets everything is multiplied, right? So you only need to multiply the 2 to the first thing. Okay, so 6.46 times 10 power negative 6. Divide by, okay, so you see square root, that means you have to power half each of the terms inside. Okay, power half to each of the terms inside. So 3.61 power half will give you 1.9 times 10 power half of 10 power 10, then you times power half. Okay, so 10 power 5. So 6.46 divided by 1.9 gives you 3.4, and 10 power negative 6 minus power 5, right? Because you divide by 10 power 5. So it's 10 power negative 11. That's how you get option 4. Alright, so if you key into your calculator, it should straight away give you 3.4 e negative 11, right? This e means 10 power. Okay, so it's a power of 10, 10 to the power of negative 11. Alright, okay, time now is 3 o'clock. There is still one last part which I don't think we have time to go through. So it's just 2 extra bubble questions. You should be able to do. I will need to check if we can put it into the Genie Ask Try It Yourself, okay, which is right over here. So this is your Try It Yourself question. So please go and try. Laws of indices, we need you to practice, okay? Laws of indices, you can only master it if you practice it enough. Alright, so go ahead and do this question. Alright, 30 bubbles up for grabs. And yeah, this is the summary. we have covered prime factorization, simultaneous inequalities, and indices, percentage. You just need to remember the formula. Okay, so if you have any questions, please feel free to stay back for a while. I'll try to answer any questions you have. If not, I'll see you guys soon. Okay, for my A-Math students, I'll see you guys next week. Okay, bye.